can do the longest question. So part of where people make this such a long question is if they don't know what else to do. There's a lot of different things you could do. I guess you could try to subtract the fractions with the common denominator. I don't know that that would be wrong. I mean, I think it can be easy. Some people change all this stuff into sines and cosines and all this stuff into sines and cosines, and 3 or 4 steps later to figure out kind of what happens. So I'm going to give you, remind you of trying to think of this a different way. If this is cosine divided by secant, dividing by secant is the same as multiplying by its reciprocal. So what does that make all of this come out? So dividing by secant is the same as multiplying by cosine. Well, not just that, but this also works that way. Dividing by tangent is the same thing as multiplying by its reciprocal. So it's like cotangent times cotangent. So you don't have to see that. It's just that you save yourself 3 or 4 steps if you happen to do that. You could achieve the same thing by changing all of this into sines and cosines, all of this into sines and cosines, and dividing the fractions, all that kind of stuff. Okay. Now it looks like we're really close, but unfortunately we still have a few steps to go. Because there's a big difference between subtracting these and multiplying them times a negative. I'm certainly not convinced that that's supposed to be true. So at this point I look at it and there's not a Pythagorean identity that relates cosine squareds and cotangent squareds at the same time. So I guess I could try to replace one of them. But this would, if I replace this one, I'd have some sine squareds. If I replace this one, I'd have some cosecant squareds. It doesn't seem to match up. So in this case, I would say, I don't know what else to do. So maybe I'll just do what kind of the last case, and I'll change everything into sines and cosines. That typically works. It does not usually fun. Now looking at this, I could say, all right, I've got 2 terms on the left, 1 term on the right. Maybe I'll try to get a common denominator and add these together. So here's what it would look like with a common denominator. Here's what it would look like with this together into one big fraction. Step is an algebra step that you do a whole lot in algebra 2, but it's just hard for you guys to see that at the beginning here. What is the most basic type of factoring? What's the very first type of factoring in there? GCF? Greatest common factor. Well, both of these have a cosine squared, so you can factor out a GCF. And this piece, cosine squared over sine squared, gives me cotangent squared, which I want. And sine squared minus 1, I have to be very careful with this. If I take the first Pythagorean identity and I solve it for sine squared minus 1, I can replace sine squared minus 1 with negative cosine. This can become negative cosine. Now I'm not subtracting them, now I'm multiplying. So now I've got negative cosine squared times cotangent squared, which is what the right side has said the whole time. So I was pretty smart about dividing them at the first step. I could have easily made this 3 or 4 more steps from here to here. And when I didn't see anything else that was going to work out for me, say almost always changing things as sines and cosines will work. But just if you do that, you might have to add or subtract fractions, which means get a common denominator. Might get you to this. You might have to factor out a GCF. You might have to see that part of this is a quotient identity. The other part is a factoring identity. Solve it very carefully so that you don't think this cosine squared, that's actually negative cosine squared. And then eventually we end up with that. So for that one,